Welcome back to the Explainer. Today, we're diving into what happens when you introduce a little bit of, well, chance into a neural network. We're going to be looking at stochastic autoencoders and see how adding probability can turn a pretty simple network into something way more powerful. But before we get into all the complex probabilistic stuff, let's ground ourselves in an idea that's probably more familiar than you think. The whole concept is actually built on a type of network you already know. Okay, so here's the key insight that unlocks this whole topic. At their core, autoencoders are just feed-forward networks. Yep, that's it. They aren't some totally new, wild architecture. So if you get the basic idea of data flowing through a simple neural net, you're already most of the way there. And this connection is pretty deep, because they have that same fundamental structure. They can use the exact same loss functions, the same kinds of output units, all of that. The only real twist is the goal. Instead of predicting some other label, the network's whole job is to reconstruct its own input, x. It's basically just trying to make a perfect copy of whatever you give it. So you might be asking, if there's so much like regular feed-forward networks, where does that stochastic part even come from? Well, this is where things get really interesting and really powerful. We're about to shift from a world of fixed answers to a world of probabilities. You see, the modern way to train a lot of these networks isn't just to get a single definite output. It's actually about learning an entire probability distribution. The model learns the probability of some output y given an input x. Then, during training, you just tweak the network to make the correct output as probable as possible. We do that by minimizing something called the negative log likelihood. Okay, so how does that play out with our autoencoder? Well, it's the same idea, just a bit more specific. The model learns to define a probability for the original data x given some compressed hidden code h. And the loss function? Its job is to push the network to make the probability of seeing the correct x pop out of the decoder as high as it can possibly be. So, with that probabilistic mindset, let's look at the first half of this machine, the stochastic encoder. This is where our input data gets squished down into that hidden code. And here's where you can really see the magic happen. A regular encoder would just map an input x to a single fixed code h. But a stochastic encoder, it maps x to an entire probability distribution for each. It's not saying the code is this one thing. It's saying, here's the whole range of possible codes and how likely each one is. All right, so we've got a distribution, a sort of cloud of possibilities for our hidden code. Now what? We have to get back to our original data, and that's the job of the stochastic decoder. The decoder's job is to do the reverse. It takes a code h. Usually, we just pluck a random sample from the encoder's distribution, and instead of spitting out one reconstruction, it defines a probability distribution over all the possible versions of x. It learns what the original input probably looked like given that specific code. And here, you can see the whole thing tied together. The input x goes in, and the encoder defines a probabilistic relationship to the hidden code h. Then we take a sample from that h distribution, and the decoder uses it to define another probabilistic relationship for the final reconstruction r. This two-step probabilistic dance is the absolute essence of a stochastic autoencoder. And that brings us to one last really important question. If the model is learning these flexible probabilities instead of just fixed points, what does that get us? Well, think about it. If you can sample from that middle distribution of codes, you can pick points that don't belong to any specific input you've ever seen. And when you run those new codes through the decoder, you can generate completely new data. This is what transforms the model from a simple copy machine into a generative model. It's not just recreating, it's creating. And that's a powerful idea to leave you with. Thanks for watching The Explainer.